All right, welcome to Chapter 4, Section 4. It's entitled Solve ax squared plus bx plus c equals 0 by factoring. So just as a quick reference, the difference between this and what we just did was for 4.3, you factored x squared plus bx plus c. You only dealt with c and b. So we had set things up like this. Let's say this was x squared plus 5x plus 6. So this would be plus 2 and plus 3. All right, something you can do in your head fairly easily once you get the hang of it. 4.4, now it throws in a leading coefficient, ax squared plus bx plus c. So now what happens with this is now you're beginning, instead of having x and x, you basically would have factors of a in the leading. You could have something like ax times x like that. And so that can cause some problems, and it involves a few extra steps, and just something that if you're organized shouldn't be too bad. So let's look. This is how the note-taking guide sets it up. This is how the book kind of shows examples of how to do it. If you want 2x squared plus 9x plus 7, it'll be in this form. All right, now here's a k, m, l, and n are all numbers. Well, for the most part, will be numbers. Where k and l are factors, k and l are factors of 2, and m and n are factors of 7. Now, because m times n, since that's greater than 0, m and n have the same sign. So m and n must both be positive, because the coefficient of x, 9, is positive. All right, this is what it means. This is what that means. If you have 3x squared plus 4x plus 7, notice that all of the signs are positive. So, and then this is like this. So if all are positive here, all are positive over here. Yeah. If you have something like 3x squared minus 4x minus 7, if all are negative, then if all are negative, then you want to say that you only have one negative. Only one thing here will be negative. So like this would be x plus something, this would be x plus something. Here you'd have x plus something, but then you would need x minus something. So it's a way to know if your answer makes sense, or maybe even to help you out a little bit. The other possibility here would be 3x squared minus 4x plus 7. All right? If this is the case, then we're going to say, what are we going to say here? If b is negative and c is positive, then you would say all are negative here, because this would be x minus, this would be x minus. The last possibility would be this, and this time you would say b positive, c negative. You're still going to have one negative over here. Okay? So that's just one way to kind of look at it to see, make sure your signs make sense. That's why here, this is plus plus, so all of them are going to be positive. All right, so KL are factors of A, MN are factors of C, so this would be 1 times 7, this would be 7 times 1. When I plug this in, you'd end up with 2x plus 1 and 1x plus 7. Or down here, you would have 2x plus 7 and 1x plus 1. Now, you might not think it makes a difference, but what it does, and I'm going to go through some example or some of my steps here. But when you now try to FOIL, if you try to FOIL this, your O and I end up being different. All right? So when you try this out, let's just do the OI part. Forget about the F and the L. Just do the OI. So that means the outside stuff, that's 14x, and the inside stuff is 1x. Does that give me 9x? You'd say no. Over here, do the O and the I. 2x times 1 is 2x. 7 times 1x is plus 7x. Does that give me the 9x that I'm looking for? And you will say, yay, it does. So my prime factor, my factorization is 2x plus 7 times x plus 1. Now using this box here is an okay way, but it involves a lot of steps. So it involves a lot of things in your head. Okay. I'm going to show you the way I set this up. So step 1 will be to write the problem. Step 2 will be to set up your answer. You're going to write out all factors of C, and then you're going to write out all factors. Oh, not all factors. You don't have to do all factors. I'm going to say write out some factors of A. All right, so what that means to me is this. Let's take this right here. All right, so we're going to go ahead and factor this using my way. All right, so we wrote out the problem. Now we need to set up the answer, which means you set up your parentheses. You put your x's in the beginning, like this. Now please notice I left a little space right here, okay? That space is because we need to put a number in there. Step 3 is to write out all factors of C. That means you have to do, and notice where I'm going to put them here. I'm going to put them under the gap. So here I'm going to put 2, -1, -2, +1, -1, 2, and 1, -2. These are all the possible factors. If this number was 12, there would be a lot more numbers here. And then write out factors. So factors for number 4. And this is some of them. When I say sum, I mean one set each. So factors of 3 are 1 and 3. I don't have to, if I do all the possible factors here, I only have to show sum here, 1 and 3. I don't have to do 3 and 1. I don't have to do -1, -3, or -3, -1. You just have to do one of the choices. So let's go back here. Step 5 is to write out some factors of A. Step 5 would be guess a factor of A and plug in. 6 will be to do OI of FOIL. You need to do the OI of FOIL to work this out. All right, so let's look at this. I'm guessing 1, 3 because it's my only choice. And then OI would be this. That's O, the outside numbers, and the inside numbers. So 1 times -1 is -1. 3 times 2 is 6. Adding them together gives us 5. I know it's not this one. Well, changing the signs, all that would do would be make this +1 and -6, so give me -5. It's not this one either. So now we look at 1 and 2, 3 and -1. Outside. 1 times 2 is 2. Inside. -1 times 3 is -3. Add them together is -1, which is exactly what I'm looking for. So I now know that these are what go in the parentheses at the top. So I take them, I put it there, I take this, I put it there, and now I know that my factored form is x minus 1 times 3x plus 2. That's what we got. That's what you got. And if you FOIL this all the way out, you should see that it's a correct answer. So that's how I set it up. I think it's less work than this table. Because this table involves, these are all the factors of KL. All the factors of 2, this would be 2, -1, -2, 1, which is what I did. But then it actually has you write out all of the possibilities. So you could have a 3x minus 1 and an x plus 2. You could have a 3x plus 2 and an x minus 1. You could have a 3x plus 1, 3x minus 2, or 3x minus 2, 3x plus 1. And then you have to FOIL all of these, right? So I'm trying to avoid doing too much work here. All right, I'd have to do all of this, and that would take a long time. If you set up the problem this way, I personally think it uses a little less room. So let's try my way a few more times. Let's try a number 1 of your guided practice. So number 1 is 7x squared minus 20x minus 3. So step 1 is to write the problem down. Then set up the parentheses. Put an x in the front. Basically, you're setting up your answer. Looks like this. All right, so what are all the possible factors of -3? Well, 1 and -3, or -1, +3. Since we have to do all of them, we have to flip these numbers around. 3, -1. So 3, -1, -3, +1. those are the factors of C. So I wrote it down, set up the problem, factors of C. Write out some factors of A now. Well, the factors of A are just 1, 7. I don't have to do any more than that. So 1 and 7 are my choices. From there, you write out, you guess a factor of A, done, and do OI. So I'm going to now look at outside 3 times, or 1 times this column, and the inside, this column times 7. Well, 1 times negative 3 gives us negative 3. 1 times 7 gives us plus 7, which is 4. Is that what we're looking for? No. So now, the other one would be 3 and negative 7, which gives me negative 4. Again, not what we're looking for. 1 times negative 1 is negative 1. 7 times 3 is positive 21. And you get 20. So what we have now is we know this is the correct combination of numbers. You put this number 3 up top, negative 1 up top, and you now have your factored form. X plus 3, 7x minus 1. And that's it. Make that 7 a little nicer. All right, guided practice number, oh, wait, we didn't do number 3 yet. Number 3, 2w squared plus w plus 3. So step 1 was to write the problem down. Step 2 is to set up the problem. Write all the possible factors of positive 3. And then some factors of A. So I'm going to put a 2 there and a 1 there. That's my guess. Now do OI. OI is all you have to do. 2 times this column is 6. This column times 1 is plus 1. And just keep going down the line. 2 times negative 1, or 2 times 1 is 2. All right, so those are the 5 possible answers. Do any of them end up equaling this number right here? You're going to say, no, none of them work. So you would say not factorable. Not factorable. That's how this one plays out. Guided practice number 5. 4, I'm just going to use x, 4x squared minus 9x plus 2 is the first step. Writing the problem down correctly. Once you've written the problem down, you set up the answer. You know there's going to be a number there or here. So this was step 1. Step 2. Step 3, what are all the factors of 2? 1 and 2. Negative 1, negative 2. And the reverse. 2 and 1. Negative 2 and negative 1. So those are factors of the 2. Now let's look at some factors of A. 2 times 2 or 4 times 1. Remember, if you write all of the possible factors of C, you only have to do one set of the factors for A, and vice versa. If you do all the possible factors of A, you only have to do some of the ones of C. So let's go ahead and guess one of our numbers. It doesn't matter which, but I'm going to guess 2, 2, and see if it works out. If it doesn't, I start over. The outside times the inside. That's 2 times 2. 2 times 2 is 4, plus 2 is 6. So the next one would give me negative 6. 2 times 1 is 2, 2 times 2, 6, and negative 6. None of those give me the 9. That does not mean that this is not factorable, well, yet. It just means that I have to try, that this, I've now tested and shown that does not work. 4 and 1. Well, outside, 4 times 2 is 8. Inside, 1 times 1 is 1. You end up with 9, which makes you happy, except that this is negative and this is positive. All that means is now you can pretty much guarantee that next factored minus 1 minus 2 is the factored form. 4x minus 1 times x minus 2 is factored form. All right, this video is going to be a little bit long, but what we're going to look at here now is the fact that you have the problem's already written down. You know it's an x here and an x here. You know the factors of 20. 1, negative 20. Negative 1, 1, 20. 2, negative 10. Negative 2, 10. 4, negative 5. Negative 4, 5. And then the flips are true as well. You really should get in the practice of doing then the other side. 5 and negative 4. Negative 5, positive 4, and so on. It goes all the way down again. There are a lot of them. And some of you may find some little tricks here and there to make it a little even easier for you to do this. But for right now, this is what you got. Factors of A are 3 and 1. That's it. So I put a 3 here, I put a 1 here. And now I do O and I. 3 times 20 plus 1, not going to work. This one's not going to work. 3 times negative 10, negative 30 with 2. Definitely not going to be this or this. 3 times 5 is 50. So now we're doing 3 times negative 5 is negative 15. 3 times 4, right, 1 times 4, I'm sorry. Let's make sure we do this right. 3 times this column, 1 times this column times 1. Negative 11. Not what we're looking for. That won't work either. Now, 3 times negative 4 is negative 12. 1 times 5 is 5. Adding them together gives us negative 7. Now, that's not quite what we're looking for, but it's very close. We should know this is not the right answer, but these are. So all you have to do is take this number and put it up at the top. Let's do some more examples. Let me erase some of this. All right. Factors, or it's already written down the problem. Let's set up what the solution should look like. You know, factors of 6 are 1, 6, negative 1, negative 6, 2, 3, negative 2, negative 3, 3, 2, negative 3, negative 2, and then 6 and 1. That's the factors of C. The factors of A are 1 and 5. So I go ahead and put a 1x and a 5x. Do the outside and the inside. So 1 times 6 is 6. 5 and 1 is 5. Gives me 11. Not what I'm looking for. Not the right answer. This would give me negative 11. And that's not what I'm looking for either. One times 3 is 3. 5 and 2 is 10. So what we've got now is we're using this one here. 5 times 2 is 10. 1 times negative 6 is 4. Or negative, wait, 10. Oh, I'm sorry. I was looking at the wrong numbers here. I'm looking at the 1 and the 3, which is 3, and the 5 and the 2, which is 10, which gives me 13, which is not quite what I'm looking for. And when that happens, I know now this is the right answer. So I take that number, put a negative 2 here, put a negative 3 here, and I now know that my final answer is x minus 2 and x minus 5. All right, there are some special patterns for this that we need to remember. There was this that we dealt with in a squared minus b squared, and this was just the opposite sign of all this. But it could be that you have ab squared minus cd squared, and now what you end up with is you end up with exactly what you thought, ab plus cd, and then ab minus cd. So you're going to have to remember some of that. You also have this, if you have had x squared plus bx plus c, a perfect square trinomial. I'm sorry. It wasn't written quite like that. I'm going to start with a plus b squared ends up equaling a squared, a plus b squared at the end, and a plus 2abx. Right there. Oh, I don't need the x's in there. So minus 2ab. So now what you're going to, and so that's basically how this is set up. These are the special patterns from 4.3. So take a look at this. This is a perfect square. This is a perfect square. It's a difference. So all it is you put that this is 2x squared minus 3 squared. So you end up with 2x minus 3 and 2x plus 3. It's a special pattern. Here, notice 9y squared. That's 3y times 3y. And that 49 is 7 squared. So if all you're doing is you're taking this part, 7, 3y ends up being 42y. So you should like the fact that this becomes 3y plus 7, and you're squared. Over here, it's the same deal, except it's a minus sign. So this is 11 squared. This is 5t squared. And inside, it's 5t, and it's 11. And so all together, it should be 5t minus 11 squared. So let's do guided practice number 7. 16x squared minus 1. Perfect square, perfect square. All you really have to do is in your head square root it, and you get 4x and 4x. Then you get minus 1, and you get plus 1. Number 9, 4r squared minus 28r plus 49. All right, well, even when it's a triple like this can be square rooted, this can be square rooted. And now what you have is you have 2r squared there, and you have 7 squared at the end. So you're looking at the fact that this is 2r minus 7 squared. Number 11, 49z squared well, 49, you can square root it and square root this. So it becomes 3 squared on the end, 7z squared on the outside. And now, since it's, is that a plus right there? For number 11? Yeah, they're all pluses. They're all pluses. And so now that means 7z squared, and it's simply the plus 3 part. That's doing the patterns. The patterns will make things a lot easier for you. So, like I said, this video is going to be pretty long, but square root this, square root that. That means 4y squared. This means 5 squared. So my answer should be, and we're hoping that the answer is 4y something 5 squared. Well, look, a minus and a plus. They're not the same, so it's a minus sign. Here we go. Square root, square root. It's a difference of squares. So the square root of 4x squared is 2x. And the square root of 81 is plus 9, and then minus 9. Those are the special patterns. All right, we just did a lot there. We're not done yet because now we have to factor out monomials. Factoring out monomials involve looking at a problem and basically factoring out most in common. So factor out what you have most in common. All right, this was almost like an undistribute. So this example here, 4x squared minus 4. You should ask yourself, what do they have in common? Well, they have a 4 in common. If I take a undistribute a 4 out of there, you're left with x squared minus 1. Looking at this, negative 3, 18, they all can be divisible by negative 3. Y and y, take a y out. So if I took a y and a 3 out, take a 3 negative away there, that's y. Take a minus 18, divide by negative 3y, the y's cancel, and you end up with plus 6. Down here, negative 4m minus 10m plus 24. They do not have a variable. All of them do not have a variable in common, but they do have a negative 2 in common. So you basically take a negative 2, take a negative 2, take a negative 2. Negative 2 times 2m squared, negative 2 minus 5m, and negative 2 plus 24 would be plus 12. No, it's a negative, so it's minus 12. There you go. Now, once you get to here, you should then do the factoring. 2m squared minus 5m minus 12. Set up the factored form. Put in the variables, leave some space, all the factors of negative 12. All right, I'm going to write them all down, but right now, you know that this is going to be 2 and 1. So, outside, 2 times negative 12, negative 24 with a 1. No way this is going to work. No way this is going to work. 2 times 4 is 8. Oh, let's make this negative 8. 1 times 3, that ends up being negative 5. These are the exact numbers we're looking for. So my total factored form, 2m plus 3, m minus 4. All right, so look at this. What do they all have in common? Divisible by 5, divisible by 5. All of these can have a 5 undistributed. So take a 5 out of there, it's z squared. Take a 5 out of there, it's minus 5z. Take a 5 out of there, it's plus 8. And there are no factors of 8 that add up to this number here. Oh, I left this space here. It should be x plus 1, x minus 1, because, again, it's a special pattern. All right, let's do some guided practices. Let's look at number 13. 3s squared minus 24. 3s squared minus 24. These are not perfect squares, but they can all be divisible by 3. So take out a 3, and let's see what we get. All right, so unfortunately, s squared minus 8, this is not a perfect square. This is as far as you can factor it. 15. 6x squared plus 24x plus 15. All right, now let's make our life a little bit easier. Let's see that both of these are divisible by 3. All of them are divisible by 3. So we're going to factor out from every term a 3. And now that equation does not look as scary. So, and now with this equation, I can go ahead and say, set up my parentheses. Put a 2x and a 1x. Factors of 5. Oh, not 2 or 3. I think that's pretty much it. Oh, the other way around, though. So I'm going to go then 5 times 1, and negative 5 times negative 1. So, OI, 2 times 5 is 10. 1 times 1 is, so 10 and 1, not going to work. That's not going to work. 2 times 1 is 2. 1 times 5 is 5. Not going to work, not going to work. There are no possibilities here that work. Therefore, this is your answer. Number 17. I'm doing a lot of the guided practices for you. That's why this video is a little bit longer. Number 17, negative 16. n squared plus 12n. Well, let's see. What do they all have in common? Well, the numbers can be divisible by 4, but they also have an n in common. So we're going to take out a negative 4 and an n. And what are we left with? 16, negative 16 divided by negative 4 should give me 4n squared. No, just 4n. And then 12n divided by negative, that's a minus 3n, or minus 3. And once you get there, you're done. All right. So we're getting very, very close. And this part right here is exactly like we've been doing. It's factoring. Factor this. We know this is going to be a 2x. This is going to be a 1x. We know the factors of negative 21. We put here, so 1, 21, 7, 3. And there's more, but that's as far as we need. So OI, 2 times 3. I already know, I think this is the answer. 2 times 3 is 6. 1 times negative 7 is negative 7. Adding them together gives us negative 1, which is what we want. So my answer is 2x minus 7 times x plus 3. So the zero product property says that for this to equal 0, then 2x minus 7 equals 0, and x plus 3 equals 0. So when you solve, that's negative 3, and we've got 7 halves right here. All right, this next one. We have to make it equal to 0. It has to be in standard form. So I subtract 6r from both sides. I add 12 to both sides, and you get that. You then divide each side by 4. You're basically factoring a 4 out of there. And now, look, perfect square. Perfect square. So we're hoping it looks like that. That's what we hope it looks like. All right, r times r, and then it should be minus 3. Yep, negative 3 times negative 3. Negative 3 times 2, that's right. So the zero product property now says that that has to equal 3. So r minus 3 equals 0, so r is 3. 3 minus 3 is 0. All right, I don't want this video to be too much longer, but you're going to factor, let's do number 8. All right, z squared, well, I have to minus 5z and plus 4 on both sides. So I end up with z squared, so minus 5z plus 8z plus 4 plus 16. Please notice perfect square, perfect square. I hope the answer is this. So let's check. 4 times 4 is 16. 4 plus 4 is 8. Good to go. If this is equal to 0, you then have to say that z plus 4 equals 0, and that then z equals negative 4. All right, we're going to do a lot of this in class. Here's your practice problems we'll do in class. Make sure you finish the guided practices. Good luck.